Do you need to make cutouts in your shapes in Designspark Mechanical? Even the most detailed cutouts can be quick and easy, and in this video I'll show you how I do them. So I am building this little gear reduction box, and I'm using Designspark Mechanical, and inside I have a belt drive system, and I have a couple of these tensioners that have to slide into a grooved slot to tension the belts. These tensioners have needed some real intricate little cutouts so that the block can slide back and forth to push up against the belt to tension it. Since I'm waiting on my parts to print on the 3D printer, I figured I'd take a minute and show you how I do these really quick. So just to back up here just a little bit. So I've made these little tensioner blocks, and they've got these little tabs, and the tabs run inside of a little grooved track inside of the housing for this little gearbox. So if I pull up the model of my little tensioner block itself, I can show you how I make cutouts off of it. I suppose I should back up one step farther and show you my model of this little bearing first. So when I have little parts like this that I use over and over again, like I've said in my previous videos, I model these and save them separately so that I can import them into any assembly drawing that I'm doing. But I go one step farther when I'm modeling these items, and I create a cutout model as well. If I come up here and turn on my cutout solid and quickly go to a cross section of this part, I can show you what I'm talking about. So when you go to insert a small bearing or any two mechanical parts together, you need to have some type of mechanical clearance so that they will fit together. I always try to model my parts to the exact size, but then that brings up the issue of always needing to add clearance to your parts every time you use them. So this is my little trick to avoid having to do that every time I use the part. I model the part, and then I make another model that's a little bit larger than it that I can use for making my cutouts. Let me show you how that works really quick. I've got a little mock-up here. This is just a model of a solid and that bearing imported into it. So like many times when I need to put a bearing into a part, all I have to do is import the bearing, move it into position where the face of the bearing is just exposed on the surface of the solid, and then I can go up to the structure tree and turn on my cutout solid, and that will allow me to make a cutout in this solid that is just a little bit oversized for my bearing to fit. Once I have my bearing positioned exactly where I want it to be, then it's a simple matter of using the Combine tool. All you have to do is click on the Combine tool, and it's telling you to click on the target object, which that would be my solid block, and then it says click on or select a cutter object, and that would be my cutout solid. And if you look over in the structure tree, what that did was that created some more solids. Now it is asking me to select the regions that I want to remove, or press Ctrl and click to select additional items to cut. I don't need to cut any more items, so I'm ready to remove the parts that I don't need. So what I do is I'll turn off my solid, I'm going to turn off my bearing, and then if I come up and look at the solids that it created, that's the one I want to keep. This one I can remove, and this is that additional space that I can remove. And just like that, you can see I have a cutout in the shape of my bearing in the solid. So it's important to realize that the tool is still active, so if I click on anything else, it's going to try and remove it. So I either need to hit the escape key or hit the select button up here to get away from the Combine tool. Now if I go turn my bearing back on, we can take a look at it real quick. And if I zoom way in on it, you can see that the bearing is in place, and there's a little gap both around the outside of it and around the inside of it in my solid. Now let's go back and look at that tensioner assembly again. So if we go look at the structure tree, I've got the solid of the tensioner, I've got the bearing assembly, I've got the axle, and I've got another solid that I've called cutout. If I turn on that solid, then we can see what I've got going on here. Again, I've made a solid shape that has a little bit more clearance all the way around the outside of it. In addition to that, this little tensioner uses a bolt to push against the back side of the block to push it into the belt. So what I've made is another solid shape that will allow the screw to be threaded through the small hole to push against the back of the block, and then there's a larger cylinder for the screw head to go down through my solid part no matter where I have to install it. I've also made some details that give me clearance for the bearing to slide in and out of the groove too when the tensioner is retracted all of the way. Since right now I don't always know what the shape of the solid is going to be that I will insert this into, I've extended the front face out quite a ways, and I've extended the cylinder for the screw head so that no matter where I install this into a solid, the cutouts will go all the way to the outside edges of the solid. Now whenever I do these, I always save them as another component in the design of the item itself. That makes it really simple to just turn it on and off as I need it. You can make your solids however detailed you want them to be used as a cutout. As long as it's in the form of a solid, it can be used as a cutout from any other solid that you choose. Let me go back to my example and show you this. Let me zoom out and let me turn on my other solid here. And I have imported that same tensioner assembly as well. Let me zoom out farther so that we can see it. So here I've got a little bit bigger block, and I've got the solid of the cutout for the tensioner block turned on. So just like we did with the bearing, it is a simple matter of hitting the combine tool, selecting the solid that you want to cut, and then selecting the solid of the component that you want to cut it with. And once again, if we go look at the structure tree, it's added a solid here. To make this so that we can see it, I'll turn off the tensioner block. Then if we go up on the tree, that's a part we want to remove, and these other two are the solids that we want to keep. And once again, remember our tool is still active, so I'll go up and click the select button. Now the process is finished, and if I go to the section view and click on a section in here and then move our plane, you'll be able to see just exactly how this cutout is throughout the center of that solid. See how easy that is? This was the exact same process that I used to create the channels for these tensioners to go in this model. If I do the same section plane thing again here and move my plane up just a little bit, you can see that's exactly what I've got here. This is my tensioner block and the hole for the screw to go through and the hole for the screw head. And if I zoom in really close, you can see that there's just a little bit of clearance around the outside of that tension block in my cutout so that it will slide forward and backwards. This same process can also be used for notching pipe. To me, this is probably the neatest use of this feature. I build a lot of stuff out of pipe, and sometimes it's really hard to visualize how you need to notch two pieces of pipe to make them fit together. And using this same trick makes it super easy. So here I have two pieces of pipe coming together at a 90-degree angle, and all I need to do to notch one pipe is to again go up to the combine tool, select the pipe you want to cut, select the pipe you want to cut it with, and then for me it's always just a lot easier to see it if I turn that pipe off, and then you can rotate around and see which sections you want to remove. So I want to remove that one, I want to remove that one, and I want to remove that one. And right there is exactly how I have to notch that pipe out so that it will fit my other pipe. But I can't stress enough, the tool is still active, so make sure that you either hit the select button or hit the escape key. Now we can see our pipes fit together perfect. And if I go turn off my number one pipe again, I can inspect really close to see exactly how I'm going to have to notch this pipe so that it fits on the other pipe. I can show you this process one more time. Let me turn on that pipe, and I've got another pipe here that's at a completely different angle. And once again, it's the same process. You select the combine tool, you select the item that you want to cut, and then you select the item that you want to cut with. And then you can go up and turn off your pipe that you cut it with. And then we can see I want to remove that part, and I want to remove that part, and I want to remove that part. And now we can see how that pipe would have to be cut to fit exactly on the outside of the other pipe. So there you have it. There's a quick how-to on using the Combine tool to make cutouts in solids in Designspark Mechanical. If you have any questions, leave a comment in the video. If you thought the information was useful, you might hit the like button. If you haven't yet, make sure you subscribe to the channel and ring the bell so that you stay up to date with all my future videos as I release them. And once again, thank you for watching.